Example 4 looks a lot like what we've been doing, but there is one key difference. Here, they want f composed of g of x. This is the first time that I don't have a value for x. Up until now, we've always had f of g of 1, f of g of -2, f of g of 1. We always knew what x value we were substituting in and evaluating. Now I want to come up with the entire function of when I compose f with g. So my new function, first expand it out. So we have f of g of x. We start these the same way. I first want to substitute in what my g of x is here. So we're going to have f of my g of x is 3x plus 1. And now I'm going to go to my f of x function, and I'm going to replace this x with what I have in parentheses. So now this becomes 3 plus 1 squared. My math lab will more than likely, I would assume, take that answer. But we also need to be familiar with expanding that out. So that would be the same as x plus 1 times x plus 1. Then you would FOIL and combine your like terms. And so we would get 9x squared plus 6x plus 1. So those are equivalent answers. Part B, going the opposite way now. Will this be the same as one of these? Well, if you remember from last video, they are not the same value. So more than likely, they're not going to be the same function. So let's try. G composed of f of x is a g of f of x. So starting inside, we have g of, and then what is my f of x? My f of x is x squared. So now go to your g of x and replace this x with what we have in parentheses. So now we have 3x squared plus 1, and there's nothing I can do to this. So we are done. So as you can see, these are very different when you get these. And for the record, what we have just done, now that I have a function, now I can replace any x value in this and get my y value. So these are nice. Now we have f composed of f of x. So f of x. Starting inside, what is my f of x? My f of x is x squared. So now go into your f of x and replace this x with x squared. So we are going to have x squared. That's me replacing the x, and then it's squared. Power to a power, we multiply, and so that is x to the 4th. And then our last one on this page, g composed of g of x is g of x. So replace your g of x with what it equals. We're starting inside. That is 3x plus 1. And now go back into your g of x and replace this x with 3x plus 1. So 3 times 3x plus 1 plus 1. We can do a lot more simplifying to this one. Let's distribute that 3 to get 9x plus 3. Bring down your plus 1. And now we have like terms. So we get 9x plus 4. Now, I don't think I actually read the instructions. I think I just dove in. So let's go back up to the instructions real quick. And it says, for f of x and g of x, find the following composite functions and state the domain of each. Okay, I wanted to circle back to that because these all have the same domain. If we remember from module 1, we had 2 mathematical commandments for domain. Thou shalt not divide by 0. If nothing here has anything in the denominator, I don't have to worry about dividing by 0. The second one was thou shalt not take the square root of a negative number. And I have no radicals either. So if I have no fractions to worry about dividing by 0, if I have no radicals to make sure I don't have a negative under a radical, then my domain here is all real numbers. And if you want to put in, because we have no fractions, and number 2, we have no square roots. Let's continue on to the next page because we're asked the same questions, but instead of the composites within the same thing, we have just these 2 right here. Got my piece of paper. Okay. So example 5 says for f of x and g of x, find the following composite functions and state the domain. So we have f composed of g of x, which is f of g of x. Starting inside, what is my g of x function? My g of x is the square root of x. And now go into your f of x function and replace this x with what we have in parentheses. So this is 5 square root x plus 1. Let's go over here and come to the side. And let's find that domain. Is my domain all real numbers this time? Well, we get all real numbers when I have no fractions and no square roots. But this time, I do have a square root, so I do have a restriction on my domain. So I take what's under the radical, x, and set it to be greater than or equal to 0. Well, because it's just x, this is the domain. Domain is x must be greater than or equal to 0. Let's try this composite here. We have g composed of f of x. So this is g of f of x. So replace inside first. My f of x is 5x plus 1. And now go into your g of x and replace this x under the radical with what we have in parentheses. So we have the square root of 5x plus 1. Can't simplify that in any way, so there's my composite function. And let's find the domain. So again, not all real numbers because of that radical. So we have to take what's under the radical, 5x plus 1, and set it to be greater than or equal to 0. Since it's more than just an x under here like it was here, we have to solve this one. So subtract your 1 over and divide by 5. And we get x must be greater than or equal to -1/5. And one more time, as you can see, these are not the same. Example 6, same 2 questions. Find your composite functions and then state the domain. So f composed of g of x is f of g of x. Starting inside, my g of x is all of this here, so I'm actually going to put some brackets. We have f of 1/3 times x plus 4. And now go into your f of x and replace this x with what we have, in this case, in brackets. So that is 3 times 1/3 times x plus 4. And then bring down your minus 4. Now with this one, multiplication first. But it does not matter what you multiply first. So this is 3 times 1/3 times x plus 4. So I can choose to multiply these together first. So 3 times 1/3 is 1. So those cancel. So I'm left with just this x plus 4, and then bring down your minus 4. And plus and minus 4 also cancel. And so we're left with x. So what is my domain here? Well, if it is just x, we have no fractions and no radicals. So my domain then is all real numbers, negative infinity to infinity. Let's do this one. We have g composed of f of x, which is g of f of x. Replace the inside first. So f of x is 3x plus 4. Nope, 3x minus 4. And now go into your g of x and replace this x with what we have in parentheses. So I have 1/3 times 3x minus 4 plus 4. Now, order of operations, say parentheses first. So I'm going to cancel those out. And then we have 1/3 times 3x. 1/3 times 3 is 1. So we are left with x. So my domain, since this was x and this is x, it's the same as this. Negative infinity to infinity. It's got no radicals and no square roots. Now I've been reiterating and reiterating this whole time that f composed of g and g composed of f are not the same. Here is kind of our special case right here. When you do composites and you do it one way and then the other way and get them both to equal x, these are a special type of composite that are called inverse functions. And this is what next lesson will be over. And this is one way that we will verify that functions are inverses, by doing the composite in each way and seeing if we get x. So that's a little tidbit as to where we're heading next lesson.